Okay guys, believe it or not, we're in chapter 5, section 1. So let's get rolling. Basic concepts in probability. We're going to look at constructing sample spaces, compute and interpreting probabilities, approximate probabilities using an empirical method, and approximate probabilities using simulation. So let's look at what sample spaces are. A probability experiment is one which we do not know what the individual outcome will be, but we know what a long series of repetitions might come out. For example, and this is the most famous example, is if you toss a fair coin, you don't know what the outcome of a single toss would be, but you do know that if you did it about 1,000,000 times, about half would be heads and half would be tails. They actually call this randomness, even though it doesn't seem random, but randomness is actually defined as the outcome that you will get in a long series of, in this case, tosses or whatever it may be. So probability of an event is the proportion of times that event occurs in the long run for a fair coin, and that means no one did anything with it to make it weighted differently. That is one that's equally likely to come up heads as tails. The probability of tails is 1/2, and the probability of heads is 1/2. Now, I really like this graph. So this is an example of a tossing a coin. This is heads, this is tails. So proportion of getting heads would be 1 if you did it once and you actually got heads. And then as you continue to flip it a number of times, you can see that it will get closer and closer to the probability of being 1/2 in the end. So after 100 tosses, the proportion was 0.49. After 10,000 tosses, the proportion of heads was 0.4994, very close to 0.5. So similar to when we look at the limit, as it gets closer and closer to something, we can say the probability is going to get closer and closer to this number over a long period of events. Okay? Now, the collection of all the possible outcomes of a probability is called a sample space. So when we take a look at tossing a coin, the sample space is simply going to be heads or tails. If you roll a dice, the sample space is going to be 1, 2, 3, 4, 5, or 6, if it's a 6-sided die, that is. And those would be your possibilities. If you have a selection of students at random from a list of 10,000 at a large university, the sample space will consist of the 10,000 students, might be by number or by name. Now, we're often concerned about occurrences that consist of several outcomes. For example, when rolling a die, we might be interested in rolling an odd number. Rolling an odd number would just correspond to 1, 3, or 5 from the sample space 1 through 6. In this case, when you're looking at a part of a sample space or looking at a certain outcome, we call this an event. So what is the event that the outcome would be odd? Once we have the sample space, we need to specify a probability to each event. This is done using a probability model. We use the uppercase P to denote probabilities. For example, if we denote the probability that a tossed coin lands on heads, we would put P and then parenthesis heads, the probability of heads. In general, if A denotes an event, the probability of event A is denoted by P of A. All right, second objective already, compute and interpret probabilities. The probability of an event is always between 0 and 1. Well, not even between, but it can be including 0 and 1, but rarely is 0 or 1. If the probability cannot occur, it just absolutely cannot occur, then a probability is 0. If the probability is certain to occur, then the probability is 1. So what are some examples of that? Let's say the probability that I give birth to a baby bird, that would be 0. The probability that I would give birth to something that has human DNA, the probability is 1. As long as I do give birth. So if a sample space has n equally likely outcomes and an event A has k outcomes, then you're going to take the number of outcomes in A over the number of outcomes in the total sample space. So here you have Georgia Cash 4 lottery winning numbers between 0000 and 9999, chosen at random with all the possible numbers being equally likely. What is the probability that all 4 digits are the same? Well, first you need to figure out how many times could you get all 4 digits are the same. So you could get 0000 or 1111 or 2222, and you do that and you'll see you have 10 times that you could possibly get all the numbers that are the same. So you're taking a look at the possibilities. The total possibilities are 10,000, and the probability of the event would be 10. So if you put 10 over 10,000, the probability that you will get all 4 digits the same is going to be 0.001 or 1 thousandths. Now, sampling an individual from a population is a probability experiment. The probability is the same, or the probability is the sample space, and the members of the population are equally likely outcomes. So here we have 10,000 families in a certain town that are categorized by the following. Either they own a house, own a condo, rent a house, or rent an apartment. So a pollster samples a single family from this population. What's the probability that the sampled family owns a house? What's the probability that the sample family rents? So we look here and we see the number out of 10,000 that own a house would be 4,753. And we're going to put that over the total, and then our probability that they own a house would be 0.4753. The number of families who rent would be renting a house or renting an apartment. So we would add those together and then put that over our 10,000, and we get 0.3769. Now, an unusual event you don't hear too often, but it's one that is not likely to happen. In other words, an event whose probability is small. There's no hard and fast rules as to just how small probability needs to be before an event is considered unusual, but we'll use the following rule of thumb. Any event whose probability is less than 0.05 is considered to be unusual. So here's a sad example. In a college of 5,000 students, there are only 150 math majors. A student is selected at random, turns out to be a math major. Is this unusual? We would look at our probability would be 150 over 5,000, which is actually 0.03. That is less than my 0.05, so I would consider this to be an unusual event. Objective 3. Approximating probabilities using the empirical method. So the law of large numbers is the one that says if we repeat an experiment a whole bunch of times, the proportion of times that the particular outcome is likely to occur to the probability of the outcome. We looked at that with tossing a coin. The empirical method consists of repeating an experiment a large number of times and using the proportion of times as an outcome occurs to approximate the probability of the outcome. In recent years, there were 2,046,935 boys and 1,952,451 girls born in the U.S. Approximate the probability that a newborn baby is a boy. So we will first add the births together, and we get a total of 3,999,386 total births, and the proportion that they will be boys will be the number of boys, 2,046,935 over the total births, which comes out to be 0.5118. So we would approximate that the probability of having a boy, based on what we looked at from our data, would be 0.5118. Now, sometimes it can be difficult or impossible to repeat an experiment many times in order to approximate a probability with the empirical method. So sometimes we can use technology to repeat an equivalent virtual experiment many times. Conducting a virtual experiment this way is called a simulation, and we can do that using our ch5 calculator. We can do it using Excel. We can do it using some written program specifically for that. Here we're going to take a look once again. We would put our information stored in list 1, and we can see that we have our random integers 1, 6, and 100. So we have lower 1, upper 6, 100 times. And then we will take a look at our result. Now, the Excel sheet can do the same thing. Ran between 1 and 6, ran between 1 and 6. That would be what you would put here in your Excel spreadsheet. And then you can do your sum by adding straight across, would be A5 to C5. So, if you have any questions about this Excel formulas here, just let me know. Now, the law of large numbers, the definition of probability, sample space, and event. How to compute probability with equally likely outcomes. The rule of thumb for determining if an event is unusual. And how to approximate probabilities using the empirical rule method. How to approximate probabilities using simulation. So this is what you should know from our lesson today. And if you have any questions, just let me know. Take care.